Hello and welcome to a video on two more triangle congruence shortcuts. Now I say two more because you've already had two. At this point, you've already seen the side triangle congruence shortcut and the side triangle congruence shortcut. Now we're going to see angle side angle and angle side. So both of these have two A's and an S, okay? So they really are very similar and easy to get confused with each other. So let's look at the difference first and then we'll sort of elaborate. Now look at the first one. These are angle side angle, and this is the side that's between the two angles, right? So that's angle side angle, and just like the name, where the S is between the two A's, in the picture, the side that has the mark is between the two angles that have the mark. Okay, now let's look at that compared to angle side. Here you see the two angles that are marked, but the side between them is not the one that is marked congruent. Instead, it's the side on the outside. So it's angle, two consecutive angles this time, just like they are in the name, two consecutive angles, and then a side on the outside. All right, so let's look at just the meaning of this one for the first one. So if two angles and the included side, that's the one that's between the two angles, are congruent to two angles and an included side of another triangle, then the triangles are congruent. So in other words, over here, if angle A is congruent to angle D, so if angle A, whoops, moved on me. If angle A is congruent to angle D, the side AB is congruent to the side DE. So if the side AB is congruent to the side DE, and the third angle, angle B, or the second angle B is congruent to angle E, then the triangles are congruent. And we'll just say then triangle ABC is congruent to triangle. Now A corresponds with D, so triangle D, and then B corresponds with E, so we'll put E in the middle, and then C corresponds with F, so we'll put F at the end. Okay? And there's other ways we could have said that. Triangle congruence statement too, but we just started in alphabetical order. So then we were forced to keep those correspondences the same once we started that way. All right, remember included means the side in between, and that is a key concept, really important to understand what included side means. So we're just going to do a little bit of practice here on looking at some triangles and naming the included side between two angles. Okay, so for the first one, we're looking at angle J and angle JLK. So angle J is right here, angle JLK is right here, and the side between them would be that one right there. So it's JL. Okay, let's try another one. Angle MKL, let's try this one in green, okay? Angle MKL, let's follow that angle. So MKL is this angle right here. And angle MLK sounds the same, but it's not. Okay, so MLK is up here. And the side between those two is this side right here. Okay, now I'm going to show you another way to do this in the last example. So that would be KL. And the last one I'm going to show you a different way to do this, and that is to highlight the actual angles. And where you can connect the side, that's the one in between. So let's try it that way. So angle M, I'm going to highlight angle M right there. Okay? Angle MKL, MKL is this angle right here. So I'm going to highlight this angle right here. Now the side that I can connect, that's the one that's in between. So side KM. Okay, you might like that method better. If you have a highlighter, you can do that instead of the dots. Okay, either way, or you can just do it visually. All right, I'm going to pause the video and you try it for the second example. Okay, there they are. So I use the dot method for the first two, and then I use this segment highlighting it in red for G and LHG. Okay, so let's look at our next, not our last one, because there's going to be one more, but we're going to look at our next shortcut now. This is the one with two angles and the non-included side. So it has to be the corresponding non-included side, and I'll tell you what I mean by that in a minute. So let's look at what we have here. So we're given two angles and a non-included side. So if angle A is congruent to angle D, we'll just write that in here. Angle A is congruent to angle D, like it's marked here. angle B is congruent to angle E. And last, if the side BC is congruent to the side EF, so BC is congruent to EF, side EF, then the triangles are congruent. So I'll just say triangle ABC congruent to triangle, let's see, A corresponds with D, B corresponds with E, and C corresponds with F. Now when I say it's got to be the corresponding side, let's just say hypothetically that instead of this and this being marked, it was this and this being marked. Okay, let's say it was those two that were congruent. That's not enough information. Those are not the corresponding sides. In other words, if the triangle ABC includes the side that's off of the angle with the 2 marks, then so does the other triangle have to be the one. So that's the way it's presented here in this diagram. And that would be a tricky case. That would be a tricky example if I gave you one that had angle, angle, side, and then a different angle, angle, side. They're not congruent. Okay, so we have to be really careful with AAS. All right, let's look at a couple of examples. Now we're going to go through the process of the sort of standard process for these kinds of problems, which is to mark the diagrams and then to determine which shortcut we're looking at. Now, any of the shortcuts are possible here, so let's see what happens. And remember, we've got 4 now. We've got SSS, SAS. Now we also have ASA and AAS. So we're going to focus on these 2, but any of them are possible now and in your homework. So let's take a look. So first, we're going to mark what we're given, which is SQ bisects an angle. Now remember, the word bisects means cut in half, and the angle RQT is cut in half, which means it's cut into 2 equal parts. So these 2 angles are equal. And it also bisects angle RST, so that's on the other side. So these 2 angles are also equal. And what else is given? Mark the diagrams according to what's given. What else is given is that, of course, the sides in between are congruent. So when we read this, we can read it as angle, side, angle is congruent to angle, side, angle. So this is ASA. Angle, side, angle. And write a congruent statement. I like to go in alphabetical order, so I'm looking here, and it looks like Q is the smallest letter. So triangle QRS is congruent to, and the Q on the top triangle corresponds with the Q on the bottom triangle, so we're going to keep the Q. R goes with T, and S on the top triangle corresponds with S on the bottom triangle. So there we have it. All right, let's look at another example. Why don't I pause the video and let you try this example? Okay, so there's the answer. There's everything marked, and the shortcut is angle, angle, side this time, because when we write it, we've got the 2 consecutive angles, and then the side goes with the 2 consecutive angles and the side. So angle, angle, side. Or, and if you say side, angle, angle, that's okay too. Usually you'll see it as AAS, but it's okay either way. Because you could start with the side and then go with the consecutive angles. When you mark the angles here, just be really, really careful. As you know, when you're looking at which angle is bisected, or when you're reading these, they tend to look really the same. So you really have to follow the angles when you mark them. So with your eyes, you follow Y, W, Z. You've got to follow the angle before you mark it. Okay, really to identify exactly which one you're talking about. It's a bit tedious, and you have to go slow and be careful. All right, let's try example 3. Okay, so this one is an angle, side, angle. I marked these in order, so the first thing I marked was this angle in here, BAC. There's BAC, so I put the mark in there. DEC, I see it up here, so I put the mark in there. They're congruent. Now, since C is the midpoint of AE, I'm focusing my attention on AE, and that C is in the middle. Now, that doesn't mark the congruence. That just tells you where the midpoint is. But since C is right in the middle of the segment AE, it forms 2 equal segments, 2 congruent segments, and that's why I marked them here and here. Okay? And then noticing that there's also vertical angles. I don't want to leave that out. I need them. I need to use them in my shortcut. So I've got another case of angle, side, angle is congruent to angle, side, angle. All right, let's try example 4. We got 3 more examples here. Now, I marked everything that was given, but I think this one needs to be maybe, we'll go through this whole process together. So I'm actually going to start with this one because it's the hardest one to know what to do with. So I'm going to erase my other marks for a moment, and we're going to focus on those parallel lines. Now let's think about that for a second. We've got parallel lines, and here we've got a transversal. So these angles here are your corresponding angles. They have to be congruent. It follows from the fact that you have parallel lines that those angles are congruent. So that's what the parallel lines tells us. So we've got that mark. Now we can put the other marks back in there. Angle ABC is up here. Angle CED is up here. And since C is right in the middle here, it's right in the middle of that whole segment AD, this segment right here. Since C is right in the middle, these two are congruent. Now, if we focus on the congruence marks, we've got angle, angle, side, and angle, angle, side. Notice that the side that I marked with an S is not the one between the two angles, it's the one on the outside, non-included angle. So we've got the shortcut here, angle, angle, side, and the congruent triangles are triangle ABC is congruent to triangle CED. Okay. Now that you've seen one with parallel, why don't you try the next example with parallel? And if you need to use a highlighter and really highlight those parallel lines, you might want to start with the parallel lines here and here. And the transversal, you've got 2 transversals. That means there's 2 pairs of alternate interior angles here. So you've got this transversal this way, which means you've got alternate interior angles here and here. And then you've got this transversal this way, which means you've got another pair of alternate interior angles here and here. I'll let you finish the problem. Okay, so we've got the 2 angles that are alternate interior angles because these lines are parallel with 2 transversals. We've got H as the midpoint of LM. So since H is right in the middle of LM, which is this segment here, since H is right in the middle, that's why I marked these 2 congruent, and that's my side, and it's angle, angle, side. Okay, why don't we try the last example? This one is all about parallel lines, except there's a shared side in the middle. So I'm going to pause it and let you guys try it. Okay, there's your first pair of parallel lines in a transversal in orange. Now I'm going to make another pair. You see if you can figure out what the congruent angles are based on those parallel lines. Now in green is the other parallel lines, JL, that's these. They're also parallel, and there's the transversal that's important for those lines. There's also some alternate interior angles. See if you can find those. I'm going to erase the highlights and show you which ones you should have marked. Okay, so there's my first pair of parallel angles, and that's because JK is parallel to LM. That's this one. Okay. Okay, there's my second pair of congruent angles based on these 2 being parallel. My second pair of congruent angles based on the parallel lines. And then the last thing is that that middle is congruent to itself. So now we're looking at angle, side, angle goes with this angle, this side, and this angle. So our shortcut, angle, side, angle. Our statement, triangle JKL. I like to go in alphabetical order, so JKL is congruent to triangle J corresponds with M, K corresponds with L, and L corresponds with K. Okay? And that's a pretty good sample of examples using ASA and AAS. I hope you found this video helpful.